Hello everyone, welcome to Gora Studies. In this video, I am going to discuss about functional interface. So in my last video, I already discussed on the lambda function. So what is lambda function that I already discussed there? Okay, so what is lambda function? So lambda function is a anonymous function. Okay, that I already discussed there. And what is anonymous function? The function not having modifier, return type and name. Okay, so what is that? Let me refresh that one. What is lambda function? So just I am taking one regular or normal, uh, Java method, that is public int add. I am passing to value int a comma int b. Okay, now see here, just I'm returning a plus b. This is a regular Java method that is basically taking two input parameter in integer a, integer b, and it's returning a plus b. That's it. Now, what would be the equivalent, the lambda function, okay, for that method? So we know that the lambda function is a is an anonymous function. Okay, so this function does not have any modifier, return type and name. So we need to remove the name, then return type, then the modifier. Okay, now let me keep all this in a single line. So how compiler will identify or understand that this is a lambda function? For that we need to use one special symbol that is called lambda expression. Now, if we have only one line there, then these curly braces are optional, that I already discussed in my previous video. So if we are not using the curly braces, then we are not going to use the return also, return keyword. It's not required the return keyword. If you are using the curly braces, then return keyword is required. But if you are not using the curly braces, then the return keyword is not required. Now the compiler, you know can understand the uh, data type of this parameter. Okay, how the compiler can understand, that we can discuss later in this video. Okay, so let's remove these two. Correct. So this is the actually lambda function. Okay, so equivalent lambda function for that Java method. Now the question is that how we can call this lambda function, because this function does not have any name, any return type, any modifier. So without name, how we will call this function? How it is possible to call this lambda function? Normally in Java, we are calling the method by using the name of the method, but here we don't have that name. Okay, so how we will call that? So to call that lambda function, the basically the functional interface comes into the picture. So by using the functional interface, we need to call the lambda function. So by using the functional interface, we can we can call the lambda function. Okay, so now what is functional interface, that we need to discuss. Okay, so what is functional interface? So we already, in Java we have a couple of interface like runnable, okay, then comparable, okay, then callable, okay. then comparator letter. Okay, so inside this interface, the runnable interface, we have the run method, then comparable, we have compare to method, callable, we have call method, and this comparator, we have compare method. Okay, compare method. So here all these are functional interface that basically we have, they are in already they are in Java. Okay, so the runnable having this run method, comparable, compare to, callable, call, and comparator, compare. So can can you tell me what is the common behavior of these four, um, basically four interfaces? Can you tell me? If you go inside the runnable, okay, then you can see the runnable interface only this run method. Comparable comparable interface has only compare to, callable interface has only call method, and comparator interface has only compare method. So all this interface all these interfaces are having only single methods. Okay, so now what, as a definition, what we can say, the interface the interface having only one abstract method is called functional interface. Okay, so suppose if any interface only one any interface having only one abstract method, then that interface we can say that is a functional interface. That is a functional interface. Okay, so the interface having only one abstract method is called functional interface. Now what is functional interface? This is clear, right? Okay, so if I write one interface here, an interface here, uh, interface, and then I'm giving the name test interface. Okay, and inside that I'm taking one method void print. Okay, so is that interface is functional interface or not? Because this interface only print method is there. Okay, inside this interface we have only this print method is there, and this is an abstract method. So we can say this interface having only one abstract method, that is print, so that it is a functional interface. Correct. Now I am writing some static, then I'm taking so. Okay, static, so void so, and I'm taking this static method as well. Now tell me, is that interface is still a functional interface, or it's not a functional interface? Because this interface has one abstract method and one static method, right? So as you know, the definition of the functional interface is saying that the the functional interface may have more than one or multiple numbers of static method and default method, but the functional interface should have only one abstract method. So you can write n numbers of static method or n numbers of default method, but if you have only one abstract method, then also that interface is a functional interface. Okay, let me show you by doing some coding there. Okay, how we can write the functional interface. Okay, let me show you. So here, if you let me create one interface. Okay, I'm giving the name test interface. Test interface. Okay, test interface. Okay, so just I am writing, one method void print. Okay, we are not getting any compilation error, right? If there is any compilation error, then you can see some red mark here, so it's a valid one. Just I'm going to so it is an a functional interface. Now I'm going to specify one static method. So now also you can see there is no such red symbol. Okay, so it's a valid one. Now I am going to write some default method, default. So I'm just writing int add, or just I'm taking only void methods there now to, to understand clearly. So now you can see this interface is not giving any compilation error. It means it's a valid interface. Now the question is that if we already have all these functional interface in Java, then what is the new in Java 1.8? Functional interfaces are already there in Java before Java 1.8 also. But then what is the new here? The new thing is the annotation. The annotation we need to use. The annotation is functional interface. Okay, the functional interface. This annotation is introduced there in Java version 1.8. And what is the role of that functional interface? So when you use this annotation, then just the compiler, it is saying that when you compile your code or the interface, then it is informing to the Java compiler that this interface is a functional interface. So check whether it is correct or not. Okay, if it is not correct, then just return error. If it is correct, then you can execute it. Okay, so what basically this annotation is saying to the compiler, Java compiler, that okay, the user is defined this interface as a functional interface. So you need to check whether it is correct or not. Got my point? So just you write any interface, and if you put this annotation, a functional interface, it does not mean that all the interface will be the functional interface. When you add this annotation will send information to the Java compiler that the Java compiler, you need to check the interface is a functional interface or not. Okay, so now we can see from here in the IntelliJ how this annotation is saying to the compiler that check this interface is functional interface or not. Okay, so let me add this interface, functional interface. So now here you can see I'm saving the code whatever I written here, but we can't see any error, right? Although we have static method or default method. Let me add another static method, uh, giving so one, and another default method, so add one. Okay, okay, so it's not giving any compilation error. It means this interface is a functional interface, right? Now let me write another abstract method here. Then what will happen? Let me write and print message. Okay, now you can see here in the annotation, functional annotation, under this you can see this red line, and what this red line is saying, let me show you the error. It is saying that multiple non-overriding abstract methods found in the interface, test interface. It means what it is saying? It is saying that more than one abstract method is there in this interface. So this interface is not an functional interface. It is a normal interface. So if you remove this annotation, then it will not giving you any compilation error. So it is a normal interface, but if you put this annotation, it is saying the multiple non-overriding abstract methods found in interface, test interface. Okay, now understood? It means from here, from this code, what you can say that any interface, any functional interface should have only one abstract method, but it can have multiple numbers of static methods and default methods. Understood? Correct? Okay. Okay. So now what is functional interface? This concept is clear, right? Okay. Okay. Let me show you another example. Okay. So here, suppose I have test interface 1, and this is test interface 1, and this is one of the functional interface, and I'm writing another functional interface, that is 2, and it extends functional interface 1, and I'm just removing this method from here. Now tell me tell me, is that correct one? This is correct or not? The test interface 2 is a functional interface or not? So here the test interface 2 extending the test interface 1, so whatever method or variable we have there in the test interface 1, okay, those will be available here in the test interface 2. So test interface 1 has only one abstract method, so that abstract method also inherited there in the interface 2. So the interface 2 also have only one abstract method, and it should also a functional interface. Okay, okay, let me show you. So this is a test interface. Okay, I'm creating another interface, new, and Java class interface, that is test interface 1. I'm giving the name. Okay, let me remove all other methods so that you can understand properly. And now let me extend it. Extend ex, extends interface to. Okay, so this is okay. Now it's correct only. Okay, now I'm going to use the functional interface in annotation. Okay, now you can see it's not giving any compilation error. It means it is correct. Okay, even if you just if you use this method, then also it's not giving any error because this method and the name of this method and this method are same. So this method, the void print method of interface, the test interface is overridden by this method, so that still the test interface 1 has only one abstract method, so that this test interface 1 is functional interface. Now see the interesting thing. Just I'm removing everything. I'm removing everything and I'm writing another method. Now see, now it's giving the compilation error. Then why? Again, it is saying multiple non-overriding abstract methods found in the interface test interface 1. So it is saying that the compiler saying that okay, inside this test interface 1 we have multiple abstract method, but we can see only one abstract method. So but that is not the case. We know that the test interface 1 extending test interface also. Okay, so that's why the method present here inside this test interface that also inherited here in the test interface 1, so that here in this test interface 1 you can see it has only one abstract method. This method is its own method. Okay, own method. The test interface 1 has this abstract method, and also this interface, the test interface 1 is getting another method from its from its parent. Okay, so what is the parent of this interface? So this test interface 1 is extending the test interface, so this is the parent of this, and inside this parent interface we have this method. So this method is also inherited here. Okay, now if you see typically basically the case is like that. Okay, so this interface has two methods. One is show, one is print. Okay, one is show, one is print. That's why the compiler is saying that okay, this is not an functional interface because we have two abstract method inside this interface. Okay, so that's why it's showing the compiler showing this error. And this is the basically the role of this annotation. This annotation basically send the information to the Java compiler, that Java compiler you test the interface, it is a functional interface or not. If you remove this so then you can see the error is gone. But if you remove this one, then you can see there is no such compilation error because it's not an functional interface. Even we are not using the functional interface annotation, so it's not sending any information to the Java compiler, okay, to check whether it is a functional interface or not. So it's a normal interface. So the normal interface can have multiple number of abstract methods, so it's not a functional interface, and that's why Java compiler is not giving any error. Okay, so I think everyone understood what is the functional interface. Okay, now I'm going to discuss how to call the Lambda function using functional interface. Okay, let me show you that. So this is my functional interface. This is one of the functional interface. Okay, so this is the test interface. Okay, I just corrected the name here. I started the name with a lowercase, but It should not be that. Basically, the any Java class or interface, anything, we need to start with a uppercase. Okay, so I modified that name now. Okay, it looks good. So this is our functional interface. Okay, so now tell me one thing. If you want to implement this method, this abstract method, how you can do it? To implement this method, okay, implement means if you want to write something inside this, inside the method body of this method, this print method, then how it is possible? The easiest way is that just we need to implement this interface. We need to create a concrete class. That class will implement this interface, and we can override this method, and inside that method we can write anything whatever we want. Okay, so let me do that, the simple approach. Okay, let me create a Java class, and I'm giving name test implementation. Test implementation. Okay, and this class basically implementing the test interface. Okay, now it's giving you one compilation error because the compiler is saying that we need to implement all the unimplemented method. So we have only one abstract method, we need to implement that. Okay, now if you want to write something inside that, you know, inside this method body, then it is possible now. Okay, print ln, correct, and I am just this is the implementation implementation of the this is the implementation of functional interface, correct. So this is the message. Okay, now if you want to call this print method, how you will do it? This is my main class. This is my main class. See this. Okay, this is the important things you need to understand here. So just we have one interface, we need to implement this method. So the way to implement this method is we have to implement this interface. We need to create one concrete class. That concrete class implementing this interface, we are overriding this print method, and we are writing some message here. Okay, we are printing some message here. Okay, now see, so how we will call this print method? The easiest way is that create the object of this class, this class, this class, and call this print method, and it will print the message. Let me run this program. Okay, let me run this program. So here you can see it is printed this message here. This is the implementation of functional interface. So now this message is printing there. Up to this it is very easy. Okay, even later also it is very easy. Okay, let me explain. Okay, just to see what I am doing here now. Okay, let me clear this console. Now see, this is the main, this is our main class. Okay, so what we are doing, this is our implementation class. This implementation class implementing this interface. So test interface is the parent of this concrete class. So here what we are doing, we are creating the test implementation object, and we are calling this print method. So now what Java is saying, Java is saying that the parent reference can hold the child object. Parent reference can hold the child object. Okay, what Java is saying, that parent so what Java is saying, that the parent basically, let me show you here, the parent reference can hold the child object. So what is the parent of this concrete class? The parent is test interface. So the test interface reference can hold the object of test implementation. So as per the Java concept, we can say we can do this, because now I'm telling you the test interface, this is the reference of this test interface. So test interface is the parent of this test implementation class. So as per the Java, the parent reference, it means this reference, the parent reference can hold the object of this class. This class is the child of this interface. So the parent reference can hold the object of child class. Now it is fine. If you call this method now, then also you can see the message. Okay, let me run this program. Okay, let me run this program here again. Main. So you can see this is the implementation of functional interface. This message is still getting printed if we can use the parent reference also, because Java is saying that the parent reference can hold the child object. Up to this is fine. Okay, now see the interesting part. Let me clear it. Okay, let me clear it. So what is that? What is that? This is the implementation of this is the implementation class. This is the implementation class. Inside this class, what we have? We have this method. We have this method. Okay, and we know that the functional interface, where is the lambda function? Okay, the lambda function, what is the lambda function? That we already discussed. The lambda function does not have any return type, does not have any modifier, and does not have any name. Okay, so if we convert this function, this method to a lambda function, then the what will be the format of this lambda function? Let me explain again. Just concentrate here. So this is the parent reference. Okay, it is holding the class of object of this class, and inside this class is providing this method, so just we need to copy this method and just place inside this. Okay, fine, everything is done. No, not yet, wait. So here you can see some of the compilation error. Now we need to convert this method into a lambda function. So we know that any lambda function does not have name. So I'm removing the name, removing the return type and the modifier, and we need to tell the compiler, hey compiler, this is a lambda function, so we need to use the lambda expression, this arrow. Okay, this arrow, correct? Okay, now now let me show you here. Let me show you here. Let me show you here. Okay, let me show you here. So this is the lambda function, right? So this lambda function has only one line, so just I am removing these curly braces. This what happened? Right, right. Now here you can see, here you can see, here you can see. Now this interface referring referring to this lambda function. The reference, sorry, the reference of this interface holding this lambda function, holding this lambda function. And what is the name of the lambda function here? It is invisible here, but if you see the implementation, because we took from here, the name of the lambda function is print. Okay, so now you see this this reference of this parent, okay, the parent reference is holding the lambda function. And now we can call this lambda function by using this object, and this object is the object of this interface, and this interface is a functional interface. So by using this functional interface, we are calling this lambda function, right? The print is the lambda function. Basically, this is the implementation of this method. This is the implementation of this method, right? Because we are implementing here, we are not using this class anymore. We are not using this class anymore. This is the benefit to use the lambda function. We don't need to write any extra implementation class to call any abstract method from the functional interface. Just by using this functional interface, we can call the lambda function, and this this lambda function is referring to this print method. Okay, this print method is there inside this inside this functional interface. Okay, that's why the functional interface should have only one abstract method. Otherwise if you write this line, okay, this lambda function, the how Java compiler will understand, okay, this method should be this one, or if you suppose you are writing another method, then oh my god, 1 second, print one, just I am taking the print one. Okay, just taking print one. So how this, if it is not, then it is not a functional interface. So if you remove that, you remove that, you remove that. Okay, now see here, it is giving error. Why it is giving error? Because now the compiler can't understand the which method we need to call. Means this lambda function will refer point to which method, because we have two methods, print one and print one. Okay, that's why it's giving the error. If you see the error is multiple non-overriding abstract method found in the interface here. So there we are specifying that, okay, okay, basically this interface, this is the reference of this interface holding this lambda function, but compiler is not able to identify, okay, the lambda function will call which method. The lambda function will point to which method, because we have two methods. So that's why it is saying that the functional interface should have only one abstract method, so that if we have only one abstract method, then each compiler easily can understand and find that, okay, this is the functional interface, and this interface only one method, that is print. So 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 what will happen? So this one, this lambda function will point to this print method. Okay, now it's clear. Okay, now it's clear, correct? What is that error? I think I don't have any error. Okay, let me run this now. By using this method, we can call this lambda function. Okay, lambda function you can call multiple time, I'm calling here 2 times. Now see, if I run this main class, okay, this this message should be printed, so that you can understand this one. Okay, this function, this lambda function is pointing to this print method. Now you can understand if this line is printed, then okay, let me run it. Okay, so now you can see that this message is printed 2 times. Okay, so now I now understood how we are calling the lambda function using the functional interface, and the lambda function basically pointing to the method, okay, which is present inside this functional interface. Let me take another example so it will be much clear. Okay, let me take a method here, int 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 a int a and int b. Okay, int a and int b. Now here let me remove this and override this method. Okay, and okay, wait, just let me add. Okay, and int add, and it will return a plus b. It will return a plus b, correct? Okay, now we don't have this thing, we don't have this one. Okay, the same way, what we can do, we can create the object of this implementation class, and we can just call the add method, add, and we are passing to value. I'm giving whatever, say 4 and 8, 4 and 8, and the semicolon. Let me run this program, and you can see it will print the value of the addition of 4 and 8. Okay, 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 okay. We just we need to print it. Okay, just I'm taking, it's not printing. Why? Because we are not written any sys out. Just I'm taking int n equal to this. Okay, or else don't. Just I'm taking inside system out dot println, and just I'm calling this one. I'm calling this one. I'm calling this one. Okay, okay. Now it should print. Let me run again. Okay, so here you can see it's printing 12. Okay, now understand the same concept. This is the same concept. This is the parent reference holding the object of the child class. Okay, correct. Now inside that we have this method. Just I am taking this method. I don't want to call this class again. I don't want to write this class in between, this main class and the interface. Just I am putting the complete method here, and I am converting it to a lambda function. So removing the name, return type, and modifier. Correct. And let me. Oh, something happened, right? I missed that one. This one, and I'm taking the lambda symbol, so that the compiler can understand this is the lambda function, right? Now up to this fine, right? So again I'm telling you that I already explained in my last video, that if we have only single line there in here, then these curly braces are optional, so we are removing these curly braces. If curly braces are not there, then we don't require the return, we don't require this return keyword. Java compiler can, you know uh, understand that the basically Java compiler can understand that, okay, it will return some value. Okay, So this I already explained in my previous video. Let's see. Now again, I already told you that here, that okay, this data type is also optional. Okay, this data type is also optional. Okay, so we can remove that data type. Now question is that if I remove the data type, then how the Java compiler automatically understand the type of this, type of this, type of this, data type of the data type of these variables. Now see here. So this method is basically referring the method present inside this functional interface, right? This is the function. This function is pointing or referring the method available inside this interface. So what is that method? The method is this one: int add int a int b. So this is referring basically, this is referring. Even if you go here, okay, where here, go here, you can see we already specify here the type of the variable a and b. So as this function is referring this method, then Java compiler easily understands, oh, the type of a is int and b is also int. Correct. That's why this is optional. We don't need to specify the data type here again. Java compiler can understand from here because this function is pointing to the function, the method present inside this functional interface. And that's why the functional interface should have only one abstract method, so that the Java compiler can understand, okay, this function is pointing or referring to this method. Now, right, now by using this object, the object is this not this is the reference of this class, sorry, this interface. Okay, so by using this interface, the reference of this interface, we can call this function. This is the lambda function. Okay, now we can understand. Okay, it is clear, right? Because you can understand now that, okay, by using this reference, and this reference is for of this interface, we can call this lambda function. Okay, so this lambda function is basically referring this method. So we just need to call test implementation dot add, and if we pass 4 comma 8, okay, we are not calling anymore this implementation. Let me delete this implementation class, okay, and run this program. So you will get the value. I'm changing the value now. I'm giving 200 and 800. Okay, now see, this is also this giving you the output of this, no, the output from this lambda function. Okay, so let me run it and show you. Okay, so you can see it's printing the sum of 800 and 200. This is 1000. So I think everyone understood, okay, what is functional interface, what is lambda function, and by using the functional interface, how we are calling the lambda function. Okay, so that's it in this video. Thank you for watching. See you in the next video.